My name is David Herald, and I work at the University of California, San Diego. I actually run the clinical chemistry lab at the VA hospital. I think the biggest shift is that mass spec provides a lot in the way of not only sensitivity, specificity, ability to multiplex samples, and so that you can get more information at lower cost. The other thing that it provides, if it's developed correctly, is you can get results as fast, if not faster, than some of the classical methods, so that you're able to provide treatment. Rob Fitzgerald and I measured testosterone by negative chemical ionization in 1996. And up to that time, it really hadn't been measured in the clinical lab. And the reason that we did that was some clinicians would order testosterone and free testosterone. And people were complaining the overutilization of the laboratory. So I called these guys up and said, why are you measuring both of these? And they said, well, I look at both the values, and if I don't agree with either one, I go with my gut feeling. And I said, wow, maybe we should be looking at a test that does this better. We did, and it really sort of kicked off things from the point of view that we discovered that in women and children there was an interference in the immunoassay that made it virtually impossible to measure testosterone by that. In fact, you would say that it's a guess. Anybody can push a button, but really you want somebody to be able to understand that after the button's pushed, what happens, and when the results comes out, what are the possible problems that can be there? Or what are the further applications of that technology to provide more health care? And I think that's the problem, is people seem to be a little bit unwilling to make that investment in people that have done postdocs in clinical chemistry after they do their PhD in mass spectrometry. Because these people are exquisitely trained to be able to provide really high quality insights on how mass spec can be better used for healthcare. One of the utilizations of high resolution that we've done is the determination of hemoglobin variants. And there's lots of hemoglobin variants. There's like 1,600 different hemoglobin variants. And most of them, obviously, there's 1,600, so a lot have been determined. And when you think of the possibilities of what's out there, there's not a lot of undiscovered ones. But in conjunction with Don Hunt's group at the University of Virginia, we have discovered a new unreported hemoglobin, which is sort of a high point for the week, so to speak. If you can provide better health care for people, you are going to have a better outcome for humanity, which sounds sort of cheesy, but on the other hand, I think that's really what we all want in the long run. We may not be able to say it, but that's what it is.